For part 3 for solving systems by elimination, I decided to break actually part 3 up into 2 segments. So there will be 2 different systems for each one, but the reason for that is because we're gonna I want to show you a couple examples on how we can manipulate systems slightly so we can use elimination. Back in part 2, we ended up multiplying our system, one of the equations of our system, by -1. That enabled us to actually cancel out, eliminate one of the terms once we stacked it. So we can build on that, and instead of multiplying by, say, -1, we can multiply by other numbers as well. So in both of these parts, part 3a and part 3b, I'm going to show you how we can multiply by multiple numbers and get the desired effects we need so we can actually eliminate the systems. So if you look at our system now, here we have equation 1 and equation 2. Now, if you recall, in part 2 and in part 1, to eliminate a system, we're looking for terms that have coefficients that are already inverse operations or that have the same coefficients. Well, if you notice, in both of our equations, neither of that is true. Look at the x terms. This is a +3, that's a -1. This is a +2, that's a +1. So even if we were to multiply one of these equations by a -1, like we did in part 2, nothing would still cancel out. That means we have to do more than multiply by a -1. So my first step is I'm going to rewrite both of these systems stacked above each other. And remember, it's important to keep the x terms lined up, the y terms lined up, and your constants lined up. Okay, now we have a couple choices. If you look at their coefficients here, if you look at our terms, is it possible that we could multiply by a number greater than +1 to get what we desired? And here's what I'm looking at. I'm looking at these x terms here. Notice how this is a +3, but this is a -1. I'm thinking, okay, I'm asking myself in my mind, what could I do here to make it so they're inverse operations? Well, obviously this is too small. What if this was a -3x? Well, how would we make this -3x? Well, we'd have to multiply by 3. Well, we could do that. That would work. Okay, so now let's change gears a little bit. Look at the y terms here. This is a +1. So, but they're both positive, so if I were to make these inverses, I would have to multiply by a negative number, and that number would have to be the same here. So to make these cancel, I'd have to multiply this whole equation by -2. I've actually created 2 options here. I could multiply by -3 and cancel out the x's and then solve for y, or I could multiply my second equation by -2, which would cancel out the y's, and then solve for x. It doesn't matter which one we want to do. I'm thinking I'm going to go with the x's, that way I'm multiplying by a positive number. So to make this cancel out, I need to multiply by 3. So if I multiply by 3, so just like before, I'm going to rewrite my first equation up top. Now here's what my new one on my equation number 2, because remember, here's equation 1, here's equation 2, here's equation 1. I'm going to distribute this +3, so look what happens. This is going to be -3x. This is going to be +3y. This is going to be -6. Now I can add them, and notice my x terms cancel like we thought. Now look at my y terms. It's going to be 2y plus 3y, which gives me 5y, and look what happened again. My constants at the end canceled out. That's okay. Now think about this. 5 times y equal to 0. Well, obviously y must be 0, because anything times 0 must be 0. But in case you don't see that, watch what happens when I use my inverse operations. 0 divided by 5 is 0. So y equals 0. Just like before, we're going to take this and substitute this back into one of the original equations. I'm going to use the second one because it's simpler compared to the first one. So here's equation number 2. Notice I did not use my new equation number 2 right here. I'm using the original equations that the book provided. So when I substitute 0, I'm going to get -x plus 0 equals -2. So -x equals -2. I'm going to divide by -1. So x equals positive 2. So I'm going to go test my answer now. So let's put the first equation. So x is 2 and y is 0. So 3 times 2 is 6, 2 times 0 is 0, 6 equals 6. Now let's try the second equation. X equals 2, y equals 0, negative 2 equals negative 2. So we are correct. So our final answer is 2, 0. Now, the only thing we had to do different this time was this step right here. We multiply by a positive 3, so then when we could stack it, we could eliminate.